Alright, home stretch. When a motor is functioning properly from a variable frequency drive and abruptly stops running, where is the best place to lock the motor out? It would be at the motor location. Which of the following imperial scales would be the closest to the 1 to 200 metric scale? So 1 to 200 metric scale. Okay, we got which of the following imperial scales would be the closest to the 1 to 200 metric scale? So we got metric, and we want to know what the imperial, if I'm correct, of 1 to 16 inch equals. So we got 1 divided by 16 equals 0.0625, 0.0625, right? Now we're going to take our total of 12 inches and we're going to divide it by 0. This number. So we got our 12 inches and we're going to divide it by the said number and we're going to get 192, right? Divided by this number and then it's going to equal 192. So 192 is actually very close to 1 to 200. So you could see how the scales are very close. So 192 to 200. So the metric scale of 1 to 200 is the equivalent or closest to 1 in 16. Okay. So while we're here, might as well we just try to do all of them. So 1 divided by 5 would be half, right? 0.5. So we do 12 divided by 0.2 is 60. So if I take out my ruler, and I look at our metric, 60, most likely 60 for 60 is most likely most equivalent to 1 to 50 in the metric. Okay, so that was for a half. Let's do a quarter. So we got 1 divided by 4 equals, then we're going to take our 12 and divide it by the quarter, and we're going to get 48. Well, 48's even closer to the 50 than the 60. And then we'll do 1/8. See what scale 1/8 is. So we got 1 divided by 8, 0.125. Then we take our 12 divided by that. We get 96. So our 1/8 imperial is closest to our 1/100. metric, 1/8 imperial. This is inches. This is millimeters or meters or whatever. Okay. What type of sections are sections 0 to 16 and 26 of the Canadian Electrical Code considered? General sections. The Canadian Electrical Code applies to all electrical work and equipment with the exception of work on what installations of equipment? Electrical utilities. What does a punch down tool do? Terminating communication conductors. It terminates and removes excess conductor. What is the primary consideration during preparation of the electrical code? It's shock and fire prevention. Which tool would you use to conduct the thermographic testing on process equipment? Well, it says thermographic. When I think of thermo, I think of infrared. So infrared camera is a device that creates a thermal image using infrared radiation. Here we have which image represents the symbol for a triac. So for the triac, we have two diodes opposing each other with a gate, right? So that would be a triac. And I'm going to find out what B would be. C and D would be NPN, definitely. So C looks like an OR gate, but it looks a little bit different. So hold on, give me 1 minute. Okay, so here A would be a triac, B would be a SCR, C would be a XOR, and D would be a NPN, right? PNP would have PNP is pulling first, and PNP is pushing first. So that's how I remember that. An SCR would be a triac singular diode by itself with a gate. A trigger diode would look like a triac without a gate, and then the bridge rectifier, obviously, with the 1, 2, 3, 4, or got the symbol of a transformer, variable resistor, fixed resistor, variable capacitor, fixed capacitor, fixed capacitor. So one is polarized because it has that positive. So, and then we have the XOR, we have the NOR, right, with the circle at the front of it. We have a OR, we have an inverter, we have a NAND, and we have an AND. Okay. So we will continue with how should a journey person respond when an apprentice shows a willingness to perform more complex work. Basically, it's you could do it with the supervision of the journey person. This is a reactive symbol for WHMIS. In order to make a 2-inch diameter circular hole in a 5/8 inch plywood, which is the tool best, a drill and a hole saw. Which of the following types of installations does the Canadian Electrical Code of Part 1 apply to? Office building for an electrical utility. So refer to the image. What is the problem shown? So in this image, we have If the voltmeter is 0, it's saying that the fuse is good because there's no potential difference between the two leads. So here on L3, we have a potential difference between coming from the source and the other end of the fuse. So it would indicate that line 3 has been blown. So the flexible cord on a portable drill contains a green insulated conductor as one of the conductors in the cord. What is the purpose of this green conductor? It has to be a bond to ground. When hazardous materials is received on a construction site, what is to be done? The material safety data sheets info. It should be put all info on site MSD's files. Here we have 4 images, A, B, C, D, which symbol represents a timed contact. So the timed contact would be C. A would be temperature, B would be pressure, C would be a timed contact, and D would be a flow. Now, if they had, because the only thing that's not here, there's a couple. There's a float, looks like that, and then there is a limit switch, which looks like a knife. As Julia says, I've reached my limit and I'm trying to kill you. So that's how you would remember the knife. The flow switch, this one, looks like a flag. You think of a flag flowing in the wind. And pressure looks like an elephant foot. And the temperature looks like a Versace sun. I don't know what to tell you about that. But let's see if we can find some more images regarding normally open, normally closed switches and what they look like. Here we are with a couple of motor control switches. So we have a disconnect, we have a circuit breaker, we have circuit breaker with thermal trip, we have a normally open liquid level, we have a normally closed liquid level, we have a normally open pressure, we have normally closed pressure. So one thing that we can see from the normally and the normally open and normally closed is that the line between the two contacts, normally open is always below the circle on the right. Normally closed is always above the circle on the right. So here we have a normally open temperature, normally closed temperature, normally open foot, normally closed foot, normally open flow, normally closed flow, normally open limit, normally closed limit. We have a toggle here. We have non-bridging contacts. We have bridging contacts. We have push buttons. We have a normally open push button, normally closed with the line above the below the contacts. We have 2 circuit, mushroom head safety feature. That's like an emergency stop almost, and maintained contact. Interesting. On the other page, we have a normally open time to close. So you could see that the line is below. The line is below the contact on the right, meaning that it's normally open. And the arrow pushing up means it's time to close. Normally closed, time to open. So it's above the right contact. The line is above the right contact. It's closed, but the arrow is pushing up, meaning that it's timed to open. And then we have normally open, held open, timed open, normally open, timed open, normally closed, timed to close. normally open contact, just normal, and normally closed. And then we have relay timer contactor, a solenoid, a thermally operated relay, magnetic core transformer, wires connected, wires not connected, plug and receptacle, ground to earth, connection to chassis, three-phase inductor motor, direct current shunt motor, resistor, capacitor, fuse, ammeter, voltmeter, pilot light, red lens, horn, bell, multi-cell battery, a rectifier diode, bridge, thermistor, and a terminal. All right. How is the dielectric test performed on a capacitor? So between the leads of the capacitor, placing the leads of the voltmeter on the capacitor will apply a high DC voltage causing current to flow. The test will prove the insulation or dielectric strength between the plates of the capacitor. Once the capacitor has charged to the applied voltage, current will stop. If a multimeter is set to high ohms range is connected across the terminals of the capacitor, it shows a reading of 0. What is the condition of the capacitor? It is shorted. It's short circuited. So the capacitor not accepting a charge from the meter's battery, the capacitor is not working. So in the same breath, it's saying the test will prove the insulation or dielectric strength between the plates of the capacitor. Once the capacitor has charged to the applied voltage, capacitor will apply a high DC voltage causing current to flow. So yeah, if you're getting 0, it seems that the capacitor is short-circuited and it's no good. Chapter 21. All right, so here we're gonna do a quick sidebar. Couple questions. What is the range of frequencies that can be accommodated on our particular telecommunications channel called? And the answer would be bandwidth. All right, here we go. What is the range of frequencies that can be accommodated on our particular telecommunications channel called? This bandwidth. Which of the following best describes the Cat V line that is used in most homes today? It's coax. What type of signals can be transmitted on broadband coax cable? And it would be analog. So analog being anywhere from 0 to 100. What do the initials Mbps represent? Megabits per second. So it's megabits per second. What is the rate of speed of baseband coaxial? It's 100 Mbps, megabits per second. Here we have which of the following cables is the most used for broadband internet? And it's coax once again. So that's twice now. Coax is the answer. Most used for broadband internet and also most popular in the homes. So what do the initials CCTV stand for? And that is a closed circuit television. Closed circuit, it's easy to remember that because that TV, specific TV, only the person watching it can see it. So, what the fuck just happened? What is the impedance of broadband coax cable? And it is 75. Now there is another question where the answer is 50. I'll have to find it in order to make sure not to get confused. What is the minimum distance that the base of an extension ladder must be placed from a vertical wall that is 900 centimeters high? So if you have 900 centimeters, 900 centimeters, you divide it by 4, and you have 225. If you divide it by 3, you have 300. So they want the most minimum distance. So the minimum would be 225. So where's info on hazardous materials found in industrial established safety data sheets? Three-phase bank, 375 kVA, 4160 single-phase transformers. The primary conductors are protected by a time limit type circuit breaker. What's the minimum size of aluminum bonding conductor that is required to be run between the transformer's primary overcurrent protection and the transformer when the transformer is being fed with RW90XLP aluminum conductors in a run of flexible metal conduit? So from the information that we're gathering, we need aluminum conductors. So we're looking at table 4. We need overcurrent protection. We need minimum size of aluminum bonding conductor. So that's table 16. So first things first, we start with a 3-phase transformer bank, 3 kVA. So here we go. We got 75 kVA times 3. So we have 225 kVA. So now that's 225,000 VA, right? We're going to divide that by the primary, which is 4160. And we'll also divide that by 1.732 because it does state that it is 3-phase. So now that we have our FLA, our amperage, the primary conductors are protected. So I'm going to multiply that by 1.25. Right? To get the conductors. So now we have the amperage for now we have the FLA. What we need is the code book, and we're going to need table 4. Okay. All right, here we are. We're at table 4. We're talking overcurrent protection, so we're going to look at 75-degree column. We have our number 39. We have our number 39 amps under the 75-degree column. And we see here we have 40 amps. 39 falls under 40 amps. So we're going ahead with number 8 gauge from table 4, 40 amps. Okay, now that we have our 40 amps, we go and look at the question again to ask what the hell do they want? So what is the minimum size of aluminum bonding conductor? So aluminum bonding conductor. So now we need to take ourselves over to table 16. Table 16. And we're looking at aluminum bonding conductor for 40 amps. And we see over here not exceeding 60. So we don't have anything for 40, but we have 60. So we look over and it says aluminum. It's number 8. So are we sure that they want aluminum? Read it one more time. What is the minimum size of an aluminum bonding conductor that is required to be run between the transformer primary overcurrent protection and the transformer when the transformer is being fed with RW90XLP conductors, aluminum conductors in a run of flexible metal conduit? So also that it states the metal conduit is why you would know that you're in table 4 for 3 or more conductors. And the answer is indeed number 8. So The calculated three-phase 600-volt demand load for a machine shop is 384 kilowatts. What is the minimum rating for electrical service when the service conductors are to be run in single copper conductor RA90 cable in free air? So we have 384 kilowatts, right? So we got to put the kilo there. So we got our watts, we got our power. We're going to divide that by our voltage, 600. We're going to get 640 amps, right? Now that we have our 640 amps, we run in single copper conductor RA90 cable in free air. So free air would be, and they want copper. Free air would be table, what is it? 1. Table 1, no? Okay, you know what? It'd probably be easier to find table 2 than 1. So we go to table 2, right? And then we can find 1. Easier. Okay. So is this copper? Single copper? Yes. Is this free air? This is free air. And then we have our number of our FLA, which is 640. Divided by 1.732. Do they say that it's three-phase in the question? Yes, they do. Okay, so now we have our FLA of 369 and $369, and because it's free air, we divide it by 0.7. So we have 527 amps. So what is the minimum rating for electrical service? So they're not asking for conductors, they're just asking for the electrical service when the service conductors are to be run. So we need a 600 amp service to hold our 527 amps. What is the maximum rating of a circuit breaker for a freestanding electric dryer installed in a dwelling unit? So a dryer is 30 amps, so the answer is 30 amps. What is the requirement for the disconnecting means for emergency for an elevator that is supplied with normal and emergency power? The disconnecting means must disconnect emergency and normal power sources. That's rule 38091 or 38051 at the back of 38. In a commercial office space, if some of the lighting suddenly gets brighter, what is the probable cause? This is going to be a voltage surge. Now, if a broken or faulty neutral will cause some lights to go dim and others to get bright. But if you only see one side getting brighter, it's a surge. This is rule 26420. What is the minimum rating of disconnecting means for a 208 volt 3-phase 25 kVAR dry type capacitor? So disconnecting means is a multiplication factor of 135. So we're going to get our 25 kVAR. So we got our 25 kVAR, and we're going to divide that by our 208. Divide that by our 3-phase. Square root of 3. And we're going to get 69.39, and we're going to multiply that by 1.35, and we're going to get 93 amps. And if you go to table 13 and you see that it's in the range, then you would stay with 100 amps. So capacitors, hermetics, motors, If you're in the range, you size down, pretty sure. Let's check it out. We'll go to table 13, and we're going to look at our 93, right? So we have we have 93. It would be in the range of 91 to 100. We read across 100 amps. So I'm pretty sure that disconnecting means only come in certain sizes. So 100 amps would be the answer. I think it's 60, 100 amp, 200 amp, and then I'm pretty sure it doubles 400 amp. I don't know the other sizes. Where is a 3-phase 4-wire AC solidly grounded supply authority system permitted to be grounded? This is definitely at the consumer service. The grounding conductor for a solidly grounded system must be connected at one point. The consumer service, this is in Rule 10-210. Item A. What is the maximum distance permitted between straps for supporting extra hard usage? Flexible cord used for interconnection of a photovoltaic module in a solar photovoltaic array. This is pretty easy to find. Look up table contents, solar PV systems, Rule 64-210, and the answer is 1 meter. A grounding electrode is used to ground a 100 kilowatt small wind turbine structure. What is the minimum size of the copper conductor that can be used to bond the metallic tower structure to ground? If it says small wind turbine, the minimum size is going to be number 6. If it says large wind turbine, then the size is going to be number 2 aught. Given the following, what is the maximum standard rating of non-time delay fuse permitted to be used to protect the primary? The primary of what? A dielectric liquid filled transformer. Okay, no problem. We got a transformer here, and it's wet. So we need our watts, right? And it's 225,000. Divide that by our voltage of 4160. It is 3-phase, so we divide it by 1.732. We get our FLA. For wet, we multiply by 1.5. We get our new calculated FLA of 46 amps. We go to table 13. We look for 46 amps. Now transformers are in a different ball game than motors, capacitors, and hermetics. When we are in a range, for most transformers, 46 to 50, we go across. It says 50, we stay. So wet being 1.5, dry being 1.25. What type of alarm and de-energization must take place given the following scenario? Impedance grounded system, 12208, wire ground fault is present on phase A. Alarm and de-energized system within the time rating of the impedance grounding device. Okay, here we're going to need to go to section 10. They're asking about what exactly an alarm and de-energization must take place given the following scenario. Impedance grounded system. Yes, that's what it was. Impedance grounded system. So we got our section 10. Section 10. Is it not called section 10? What the fuck's it called? Where's my code book? Oh, yes, not section 10. We just put in a random code 10-100 or some shit. Just to bring us to section 10. Okay. Is this appendix? Yeah, we don't want to be in appendix B. Grounding, this is section 10. Okay, perfect. So we got grounding and we're looking for impedance grounding systems. All right, now we're here, impedance grounding systems, and they say to go to table 17. What type of alarm and de-energization must take place given the following scenario? We got an impedance grounded system and we got a ground fault is present on phase A. Impedance ground devices. I just want to read a little bit of what's going on in impedance ground system. Impeding ground devices shall. Yeah, so let's go to table 17 and see what's going on. TABLE 17. We got table 17. We got line to neutral loads are served 4-wire all voltage currents. Ground fault on current carrying conductors. Ground fault on conductor from source to impedance grounding device. What exactly do they say is happening? There is a 4-wire, a ground fault is present on phase A. Ground fault on current carrying conductors. So I guess that falls under this. Line to neutral loads are served 4-wire all voltages currents, and it lands on ground fault on current carrying conductors, and the answer is alarm and de-energize system immediately. I think that's how they got their answer. All right, when setting up a crane installation for an infrared camera shot, where should the crane be positioned in relationship to the power source for the crane? It should be the farthest end of the track away from the power supply. So any answer that says furthest away from the power supply, I guess that's what we're going to be going with. What is the maximum allowable ampacity of a feeder consisting of 4 500 kc mil copper conductors in EMT in a 3-phase 4-wire installed on the ceiling of a boiler room with an ambient temperature of 50 degrees Celsius? The feeder originates from the circuit breaker with a termination temperature of 75 degrees Celsius. First things first, we got consisting of 4 500 kc mil. All right, here we are. We go. We got a circuit breaker involved, so 75 degrees column. We got 500 kc mil has 380 amps on it. 380 amps. We also have ceiling of a boiler room with an ambient temperature. So we go to our correction factor 5A. 5C is for conductors, 5A is for ampacity. So, boom, we got our insulation of our wire would be 90 degrees, and we're going through an ambient temperature of 50. So we have a multiplication factor of 0.82. We got our 380 amps from table 2, 500 kc mil, and we're multiplying by 0.82. We get a 311.6. Correct answer for this question is 311.6. A single dwelling is supplied with power from the local supply authority. The owner of the single dwelling wishes to interconnect his own DC solar photovoltaic supply system with the local supply authority system. What is required to interconnect the two power supply systems? It would have to be an inverter that is designed to serve as a disconnect. This is in Rule 84-008. Inverter converts DC to AC and can meet requirements of Rule 84-008. Let's go look at this rule just out of curiosity. 84-008. And this is not Rule 84-008. Such sources include but not limited to capacitors. These are a photovoltaic system connected to interactive inverters that are equipped with anti Islanding protection in accordance with rule. Where a group operated isolated switch is used, visible point of disconnection in accordance with. It's not intended that this switch be located immediately adjacent to the load device referred to in subrole for low voltage feedback. The visible point of disconnection could be part of the low voltage. Anyways, it's kind of saying something similar without actually going to this rule. Where the utility loses one phase O of a three-phase system, some transformer configurations allow voltage to continue to be present in all phases. The voltage drop is where disconnected and disconnection in context of the rule do not necessarily mean disconnected means. Anyway, with respect to ground fault protection, what is the maximum permitted time delay for ground fault currents? This was in 14102. I found this by searching the index for ground fault 14-102. And here we find that it says, with respect to ground fault protection, what is the maximum permitted time delay for ground faults? And subrule 2, except as permitted by subrule 8, the maximum setting of the ground fault protection shall be 1200 amps and maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. What is the maximum permitted time delay? Maximum time delay shall be, and then it gives you your answer of 3000 amps. Okay. Refer to the image. If 240 volts AC is placed across the input terminals of a rectifier, what should the DC output voltage be? Well, the DC output voltage should be, for a rectifier, is the RMS times 0.9. So we got 240 and we multiply that by 0.9 and you get your answer of 216 for the full bridge rectifier. That's how you get your conversion to DC. Given the following, this is an unbalanced load question. And you got 120, 208 volts, 4-wire feeder and rigid PVC conduit. Conductors carry a maximum unbalanced load of 430 amps and includes 105 amps of HID lighting and 48 amps of nonlinear. So this code specifically is somewhere in those neutral conductor codes. It's 4-018. So we got 4-018. 4-018. And we got size of neutral conductor. And it says to apply 200 amps for the unbalanced load. So here we go. So we go. Instead of the 430 amps for the unbalanced load, you start with your 200. So you get your 200, you add that to the rest. So we got, includes 105 amp HID lighting. So we got 105. And we're also going to add a 48 amp of non-linear load. We got a 48 amp of non-linear load. And then we're going to equals, we get 353. Now we're going to subtract the original unbalanced load. So we got 430 of the original unbalanced load. And we're going to subtract the calculation that we just did, which is 353. We're going to get 777, and we're going to take that at 70%, so 0.7, and we're going to get 53.9. The 53.9, we're going to then add that to the 353. 353. Did I add it? Where did it go? Plus the 53.9, and we get 406.9. Now that we have our 406.9, we're going to go to table 2. Table 2. So here we are at table 2, and there's no mention of, I'm pretty sure there's no mention of breakers, anything to give us any termination temperature. So I guess we're going to go with the 90 degrees insulation of the actual neutral conductor. And neutral conductor, 90 degrees, 406. We're looking for 406. 406 will land us in a 500 kc mil. So the correct answer was 500 kc mil. Minimum neutral conductor size, 500 kc mil. All right, I'm going to take a break. What question are we on? 38. With respect to ground fault protection, yeah. With respect to ground fault protection on a 3000 amp, 600 347 volt solidly grounded circuit, what is the maximum permissible setting for the ground fault protection? We got another ground fault protection question. And if we could use the table of contents. We use the table of contents. We can look for protection. Protection of persons and properties is number 2. Grounding is in 10. Let's see what 12 and 14 have to offer. Control devices, protective devices, 161. I would say 14. I would check 14. So 14. 14-102. Ground fault protection. (14-102). And here we have, with respect to ground fault protection, on a 3000 amp, 600 347 solidly grounded circuit, what is the maximum permissible setting for ground fault protection? So here we have in 14102 subrule 2, as accepted, permitted by subrule 8, the maximum setting of ground fault protection shall be 1200 amps. So right there is the answer. So the answer is 1200 amps. What is one disadvantage of an auto transformer? It would definitely be there is no primary, secondary electrical isolation. Yeah. A lamp standard is installed several hundred feet away from the panel board that supplies it. In order to compensate for voltage drop, number 8 gauge aluminum conductors from the 75 degrees column of table 4 are selected to feed the lamp standard. What size of copper bonding conductors is required to bond the lamp standard? So I definitely had an issue with this question because I never read the ending of the question where it says what size of copper bonding conductor. They did speak about aluminum. So a lamp standard is installed several hundred feet. Panel board supplies it in order to compensate for voltage drop. Number 8, aluminum conductors from the 75-degree column of table 4 are selected to feed the lamp. Number 8, aluminum. So I guess we would start with this. We would go table 4, I guess. Table 4. We'll look at our aluminum conductors. Okay, here we are at table 4. We got an aluminum conductors from the 75-degree column. And we see our 75-degree column, 8 gauge aluminum. This is aluminum, 40 amps. So if we take our 40 amps and we go to table 16, we can then go to table 16, take our 40 amps. We have to use not exceeding 60, and we're looking at copper, so we get number 10. So the answer here would have been number 10 gauge. So if the outdoor location you are wiring will be subject to light splashing, what type of enclosure is needed? This is in 4-032 or some shit. Oh no, 2-400. 2-400. Table 65 is also here. Ultimately 2-400. How do we know it's in 2? If we look at table of contents, section 2, general rules, we look at the bottom, it says enclosures. Enclosures on page 79 would then bring us to table 65. If it is not talking about the type, we'll look at table 65, and we see here that it says the outdoor location wiring will be subject to light splashing. Dripping and light splashing of non-corrosive liquids. And we see that the 3's outdoor was and it's the location is outdoor, so we have outdoor splashing, and all of these are checked off for 3 and even for 4, but in the answers we have 3 here, so we'll go with a type 3 enclosure. So what is the minimum thickness of a flame retardant non-metallic insulated material barrier required to separate cables of different voltages in a surface raceway? Now, in a raceway, they're talking about raceways. We look in the table of contents. We understand that raceways are in section 12, page 131. So, page 131, section 12. Anyway, 12-904. So here we are under raceways in section 12. We read along. And we're at 12-904, conductors in raceways. And And we have here, except where the conductors are separated by a barrier, sheet steel not less than 1.34, thick, or a flame retardant non-metallic insulating material not less than 1.5. Answer being 1.5. A three-way wall switch used in a lighting circuit would be classified as what type of switch? It would be a single pole double throw. So this single pole switch has two throw locations for three-way switching. What is the maximum distance between supports when RA90 cable is fastened to a building's structure? RA90 12-706. We have cable ties in section 12. Okay, that's good to know. 12-706 method of supporting. Aluminum sheath cable must be secured at intervals not exceeding 2 meters. We got 12-706, number 2, mineral insulated cable, aluminum sheath cable, and copper sheath cable shall be secured at intervals not exceeding 2 meters, except where the cable is fished and adequate supports are installed if needed adjacent to termination fittings. So, mineral insulated cable, aluminum sheath cable, and copper sheath cable. RA90 falls under this. I found that out by going to table 19 and looking for RA90, and then it brought me over to this rules 12706 or something like that. What is the minimum mounting height above finished floor of the enclosure? It's 2 meters. Unit equipment is emergency equipment. This is found in section 46-302. What is the area classification of grain elevator? This is zone 21. You go to rule 18002, definitions, special terminologies. Zone 21 is defined as a location in which an explosive dust atmosphere in the form of a cloud of dust in air is likely to occur in normal operation occasionally. What is the maximum distance between supports when installing trade size 53 rigid PVC? Because they're talking about rigid PVC, we're looking at section 12. We're looking for rigid PVC, which is page 136. So we got 12, 11, 14, subrule 1, item C. And the maximum distance is 1.5 meters for 53 shade size. What is the minimum thickness of wooden boards used for supports of a 2-gang switch box? This is 19 millimeters. This is also in section 12. At the end of installation of boxes, cabinets, outlets, and terminal fittings is how I found it, page 155. What is the maximum distance from a panel board to the first support for a run of trade size 41 EMT? This is also in the same area. Installation of boxes, cabinets, outlets, and terminal fittings. 12-1406. Let's go take a look. 12-1406. Electrical metallic tubing. Supports. Oh, I found this by looking up EMT and then looking at section 12, looking up EMT, and then this was found supports within 1 meter of each outlet box, junction box, cabinet, etc. Yeah. A run of 21 millimeter rigid metal conduit is installed on unistrut. This is also a section 12. This is, I looked up rigid metal conduit, and then there's two different sizes, and you're supposed to go with the minimal size, and whatever that is. So where rigid metal conduit of mixed sizes are run in a group, the conduit supports have to be arranged so that the maximum support spacing will be of this for the smallest conduit. Which rule in the Canadian Electrical Code prescribes minimum distance between single conductor cables run with a free air rating outside of a ventilated or ladder type cable tray? This is 4-004. 1A. This rule is for determining the spacing distance to determine the ampacity of single conductors and cables. Here we have to refer the image. What is the color coding conductors used on a three-phase isolated system feeder when installed in a hospital? If you go to section 24, which has to do with patient care areas, you will know that phase A, B, and C. So it would be orange, brown, yellow. I know it starts with orange because I think of Halloween. It starts with Halloween. So the answer is B. Assume the equipment marked termination temp is 75 degrees Celsius. What is the minimum size of single copper conductor RA90 cable that can be used to feed a 2000 amp 600 volt three-phase motor control center if the cables is in free air with 4 cables per phase? So we got 2000 amps. We're going to divide that by 4. You don't need a calculator for that. It's going to be 500. So now that we have 500 amps, assume the equipment marked termination is 75 degrees. Let's go to table, and this is free air. So let's go to table 1, and then we'll from table 2. From table 2, we'll go to the free air table. Table 2. Fuck, man. I don't know why they always give me a hard time going to table 2. Like, they should make you able to, like, bookmark shit. Come to think of it, you know what? I think I actually have this in a picture of this in my gallery. That's what I should do. Table 2, but we don't need table 2 because this is for copper conductors in a raceway. They're asking about free air, right? So we got copper conductors in free air. Let's just make sure that they want copper conductors. Minimum size of single copper conductor. Yeah. So they got a RA90 cable that can be used to feed a 2000 amp. Cables is running free air with 4 conductors. So we got our 2000 amps divided by 4. We get 500. 500 amps, and we're looking under the 75 degree column for 500 amps, and we got 505 here, so we're looking at 350 kc mil. So the answer would be 350 kc mil. Which is true statement regarding wiring methods in zone 1. Threads for a threaded connection to equipment are permitted to be straight. This is in section 18-102. 3B. Metric straight threads must have a tolerance class 6G6H and must have at least 5 fully engaged threads. What is the maximum surface temp of electrical equipment approved for a zone 2 location with a temperature code of T4? So the answer is 135. How do we find this? This is a section 18 question. So, I don't know, let's say 18 and let's try like 002 or something, right? So we're at 18002, and fortunately enough, it brought us to Appendix B, which is where the answer is located. And it's perfect. We're at the start of section 18, and now we're looking for temperature of electrical equipment or whatever. So just scrolling. Gases and dusts. No. Temperature and gas groups. No, it's past this. Okay, maximum surface temp. All right, here we are. So they want to know what zone 2 maximum surface temp of electrical equipment approved for a zone 2 location with a temperature code of T4. So here we have T4 and it says maximum surface temp is 135 degrees. A switch is described as single pole, double throw. How many lighting circuits can this switch control? A single pole double throw is the equivalent of a three-way circuit. Three-way switch. So it's only controlling one circuit. They're just trying to play with you and get you to get questions wrong. So very being attentive to the wording, it is only going to be one circuit. It cannot connect two circuits to a common load. A line voltage switch must be added to equipment installed in a car wash. What type of enclosure does this switch have to be installed in? So a line voltage switch must be added to equipment installed in a car. So this is an enclosure question. And we know our code book, so we know our enclosures are in at the end of section 2. So we're going to go to 2-400. Not even going to go there. I'm just going to tell you 2-400. Yeah, let's go there actually. 2-400. (2-400) enclosures, and we have enclosures type designations and use. And what they want is a voltage switch must be added to equipment installed in a car wash. What type of enclosure does the switch have to be installed in? A car wash. Type 1 is for indoors, ordinary locations. Type 2 for use indoors where the enclosure may be subject to drops of falling liquid to condensation. Type 3R for use outdoors. Type 4 for use where the enclosure may be subject to direct streams of water. So that sounds like what we want, right? Type 4. All right, there we go. What is the minimum allowable bending radius for a 13.8 kV portable power cable with a diameter? Okay, so we got a portable power cable, and it's talking about high voltage. High voltage. So this table is around table 12. So it's like table 15. Table 15 got radii of bends, bend per minute training of the cable. Table 15. So here we are at table 15. We're looking at portable power cables, and there's two separate voltages. We have 5 kilovolts or less, and we also have over 5 kilovolts. So we look at how much kilovolts they want. 13.8. It's definitely over 5 kV. And we need our diameter. What is our diameter? 35 millimeters. So it's it's over 25 but under 50. So we got portable power, and it's the multiplication, the multiplier is 8. So we're going to do 35 times 8. 35 times 8 equals 280. So the answer is 280 millimeters. What is the term for the heat given off by electrical equipment and absorbed by heat absorbing material which is not heated by an external source? This is radiant heating. How is rigid PVC conduit to be terminated into a coupling? This is going to use solvent cement. And this can be discovered in Rule 12. I guess if you look up rigid PVC. Yeah, so let's see what exactly they did. 12-11, 12. 12, 11, 12, and it shows you that it's solvent cement is needed, and this is under a rigid PVC conduit. So there's absolutely no reason why I should have got that question wrong. I guess I was guessing, but how are automatic pilot devices normally shown in schematic drawings? They're shown in not activated and de-energized. Is the start reference point for all devices in a schematic drawing. Given the following: 600 volts, 3-phase squirrel cage motor, 20 horsepower, temperature, termination of 75 degrees, 2-meter length of 3 conductor, cable feeds a combination motor starter, taps from a 400 amp splitter, and controls the motor. What is the minimum size of AC90 cable that can be used? Anyway, so we got table 45 we're looking at, or is it 44? Table 44. You know what? Let me pause this for a second. Okay, so we got 3-phase motors. 600 volt 3-phase squirrel cage motor, 20 horsepower. So we got our 20 horsepower. 20 horsepower at what voltage? 600. Horsepower. It looks like this. It's 22 amps. Right? We got our 22 amps. And they simply want to know what's the minimum size of AC90. Okay. 22 amps times, it's a conductor question. So CSA the conductor is 1.25. And we're going to get 27.5. 27.5 at table 2, 75 degrees column. 27.5 at table 2, 75 degrees column, it looks like. My bad, I was getting ahead of myself. I was saying 22, and I was like, what the fuck? 27.5, sorry. 27.5 at the 75 degrees column, and we're looking at number 10. Okay, here, how can overcurrent protection be provided for motor fuses? Using the figure, what is the type of motor shown? We got a capacitor start induction run. This figure shows a capacitor in series with the start winding, in series with the centrifugal switch. capacitor start induction run. Okay, here we have a three-phase, another motor question, but this is a refrigeration compressor temperature termination not given. So three-phase, 208 volts, 30 horsepower, squirrel cage. Lock rotor current is 235 amps. What's the maximum rating of non-time delay fuse that can be used when the non-time delay fuse blows on startup? So the fuse is blowing on startup. So 28 gallery drive. 28 dash 708. Overcurrent protection. It's to be 50% of the locked rotor current unless such a device will not permit the motor compressor to start, in which case the rating or setting shall be permitted to be increased to a value not exceeding 65%. So we got our locked rotor current, 235 amps, and we are multiplying that 235 amps, we're multiplying that by 65%, and we're getting 152. 152 152 at table 13. $152 at table 13. So we got 151 to 175. We sized down because it is hermetic, and we got 150. 150 is a punch press has an electromagnetic release brake installed on the motor, which will not allow the punch press motor to operate. What is the probable cause of the electromagnetic release brake not allowing the motor to operate? There is no power at the electromagnetic brake. So absence of power at the electromagnetic brake will hold the brake on and prevent the motor from running. So the brake needs power to be released. So there's no power to the brake, why it won't move. So a shaded pole motor is typically used to drive equipment such as fans and blowers. What do these types of equipment require for starting? Very low starting torque. A shaded pole motor are used in applications requiring very low starting torque, such as in fans and blowers. If the centrifugal switch on a split phase motor is stuck closed, what would take place? So the centrifugal switch is what makes the start winding do its thing. But if it gets stuck closed, it's going to burn out the start winding. So the start winding uses smaller wire which has a higher resistance and will overheat and burn out if it is left connected to the source voltage for an extended period of time. Yeah, the start winding is only there to create a shift in the phase to get the motor to start. But if it gets stuck, then it's gonna burn out. Simply put, which condition would cause a three-phase motor to burn out? Excessive heat due to an overload. Excessive heat for extended periods of time will cause winding insulation to deteriorate. And that's why the overloads are there to protect the motor. So if the overloads aren't doing their thing, then the motor's kaput. contactor in a relay is humming loudly. What is the problem? It's loose laminations. The humming is caused by the changing magnetic field due to the alternating current, which induces mechanical vibrations into the laminations of the armature core. When there are small gaps between the laminations, they vibrate due to frequency. Here we have a single horsepower squirrel cage motor, 3-phase 208. What is the minimum rating of time delay fuse permitted to protect this motor? So it's my gallery. Okay. Single horsepower squirrel cage motor. So it's still 3-phase. Right? So we got a 3-phase motor. It's squirrel cage, so we're looking at the left side. What is the minimum rating of time delay? Well, we need the FLA first. So it's 1 horsepower and it's 208. 1 horsepower, 208. So it's 4.6 amps. I could already tell this answer is going to be 15 amps. But okay, 4.6 amps. We need to multiply this by the multiplier for a time delay fuse. So we'll write down our 4.6 amps here. 4.6 on our calculator. And we'll look for the time delay fuse, which would be on, was it table 29 or 37? We got table 29 here. What is 37? Okay, 37 is for motor supply conductors insulation minimum temperature rating. Table 29 is what's going to tell us what we want to know, our multiplier. So what are they asking for? Minimum rating of time delay. So we're looking at time delay for squirrel cage and synchronous. Time delay 175. So we got our 4.6 times 175. It's not showing us our calculations in the answer. It's okay, I'll do it for us. 4.6 times 1.75. All right, it's 8.05. And then I wonder, do I have a screenshot of table 13 here? Yeah, we do. Okay, so you see here, it says 0 to 15 and then 15. And we can't downsize. So 15 amps is our minimum. So the correct answer is 15. 240 volts, single phase fan motor, 10 horsepower. We got single phase this time. So we're looking at table 45. So we got a single phase, 240 volts, 10 horsepower. So we look 10 horsepower, 240 volts, 50 amps for our FLA. So we write it down here on our calculator, 50 amps. And what do they want? What is the maximum current rating of non-time delay fuse? So we gotta read very carefully. Non-time delay fuse, if we look at table 29, for single phase, all types, non-time delay is 300%. So we take our FLA at 50, we multiply that at 300%, we got 150. Take ourselves over to table 13. I don't remember where I put it. Table 13. Table 13, 150. 150. So we got 126 to 150. And we got 150. Yeah, it's not in a range. This is a standard size. So we're gonna go with that. We're gonna stay. So the answer is 150. All right. 73. What characteristics will a capacitor start motor have? So capacitor start, to me, a capacitor has to do with voltage, has to do with characteristics similar to a series circuit. So a capacitor start having similarities to a series is going to have low current and a lot of torque. So when we look at our answers, we got low inrush current and a high starting torque. So that's the answer that we're going to go with. So with the capacitor in the start winding circuit, the run winding current lags the start winding current by 90%, 90 degrees. This type of motor, as a result, has more starting torque and less starting current surge as compared with the resistor start induction run motor. Resistor start induction run. Where's my pen? Okay. So let's explain this real quickly. So we have our x-axis and we have okay. And make a little diagram to explain this to myself here. So what they're trying to say is the voltage is being held back. Voltage is being held back in the winding with the capacitor. I don't remember how to fucking draw a capacitor or some shit like that. In the winding with the capacitor, the voltage is charging, right? The voltage is charging. So the current is running ahead. The current is running ahead. This guy, he's staying to charge, so fuck it. I'm running ahead. So the current is leading the voltage. Right? So if the current is leading the voltage in the winding with the capacitor, then the current is also going to lead the current in the winding without the capacitor. So that's why they're saying with the capacitor in the start winding circuit, the run winding current lags. This guy, he's lagging. He has no capacitor. No capacitor. So he's lagging while the winding, and which winding has the capacitor in it? The start winding, right? Oh, sorry. So this is start, right? And this is run. So the start winding, this current is running ahead. So the current in the run winding is going to be lagging behind because he's going the same pace as the voltage. He's in phase with the voltage in the run. So that's why, and he's 90 degrees behind. This guy's 90 degrees behind. So that is why there's more starting torque in the start than, and less starting current surge as compared with the resistor start induction run motor. So yeah, there you go. Using the figure, what prevents the forward and reverse coils from being energized at the same time? And apparently it's the electrical interlocked. I thought I seen these dotted lines and I was thinking mechanical interlock, but Apparently, they're more focused on these, which is electrical interlock. That's okay. We got given the following 208 single phase refrigeration compressor, 5 horsepower. What is the maximum standard rating of time limit type circuit breaker that can be used for the motor? So we got a refrigeration compressor. We got 208 volts single phase. All right. What is the maximum standard rating of time limit type circuit breaker that can be used for the motor? So we got a 208 volt single phase refrigeration compressor, 5 horsepower. All right, so we're gonna go with refrigeration compressor being a cold motor, 208 volt single phase. And we want our FLA. So we got single phase here, and we got 208. So it says for full load currents of 208 and 200 volt motors in the notes here, it says increase the corresponding 230 volt motor full load current by 10 and 15% respectively. So for 208s, we're going to go with 10% on top of the current, the FLA that we're going to get from the table. So 208 volts, single phase, 5 horsepower. So we got 5 horsepower and we got 28 amps. 28 amps with an additional 10% is going to be 28 times 1.10 to include the 10% in and the 28 into the answer. We have to include 1.10%. So now we're going to equal 30.8 amps. So now that we have the FLA, it's a cold motor. So we're going to get the locked rotor current. So we multiply that by 6. We're going to get a total of 184 amps. And we want to know, what do they want? They want what is the maximum standard rating of time limit type circuit breaker. That can be used for the motor. So 184, so call it 185. We'll go to table 13. We'll look at 185. 185 lands us in 176 to 200. Because it's a hermetic, we'll drop down to 175. 50% of LRC. So we got 185 for a locked rotor current. Oh shit, my bad. It's a cold motor. So locked rotor current is 185. You divide it by 2. Locked rotor current is 185 divided by 50%, and it's 92.4. You take your 92.4, .4, 81 to 90, so it's a 90 amp. 90 amps is the correct answer. Okay, so very simply, because it's a cold motor, 208 volts, single phase refrigeration compressor, we got our 5 horsepower. We got our 5 horsepower. it was 28 amps. We needed 10% on top of it. It became 30.8 amps. Then we needed our locked rotor current, multiplied it by 6. But for the overcurrent device, it's 50% of the locked rotor current. So we divided that by 2. And then table 13, we're in a range, and we size down to 90. Refer to the image. What is the correct connection for a single phase dual voltage split phase 240 120 volt motor when the motor is to operate on a 120 volt circuit? We're going to read chapter 16, installing motors, to get this right, but I don't know, I just kept the odd numbers together and the even numbers together. I don't really know how to do this question. This connection put all windings in parallel for the low voltage connection. When an operator presses the run button on a motor starter, the motor starts but does not stay running after the operator has released the run button. What is the probable cause of this problem? It's a faulty holding contact. The start circuit is operating correctly because the motor starts. The holding contacts are defective because the holding circuit is not being maintained by the holding contacts. What is the minimum number of control conductors required in a conduit for stop, start, run, jog? The answer is 3. For the 20 milliamp signal is used to read voltages from 0 to 120. What is the voltage when the signal current is 7 milliamps? So here we have for the 20 milliamps, we have 4 to 20 milliamps, and we want to know what 7 milliamps it will be. So we got 7 minus 3 is 4 divided by 16, 0.187, 0.187, and I think we have to multiply that by 120. We have to do something with this 0.187, but let's just make sure we got this right. We have 4 divided by 16, 0.25. Times 120. Okay, sorry. 4 minus 7. Sorry, the answer is 3. 3 divided by 16. Okay, here we go. 187.5. Multiplied by 120. Okay, 22.5. So our answer is 22.5. An establishment requires that a conveyor system length be increased. How are the new stop buttons to be installed in the control circuit? So the new stop buttons should be in series with the old stop buttons. So our answer is D. Which code prescribes requirements for the removal of abandoned communication cable in lane tile ceiling used as a plenum space? Well, it has to do with fire, so it's Canadian National Fire Code. Also 2130. Why are the individual pairs of UTP and STB cable twisted? Twisting decreases crosstalk. When wiring a signal circuit for a supervised fire alarm system, which device may be connected in the circuit? So here we're talking about signaling. So signaling is things that we can see and we can hear. So we can hear horns, we can see bell strobes, lights, and the end of line resistor is the current monitoring of the whole thing. So one thing, the end of line resistor is a common denominator in all the answers, so you can't get away from that. But when we talk about signaling, we're talking about things we can hear and we can see. So the correct answer is signal devices give a clear indication to the building occupants that there is an alarm. So horn, bells, strobe lights, and end of line resistors. When communication conductors have a metal sheath, are direct buried in the same trench and at the same horizontal level as electrical power conductors, what is the minimum separation required? The answer is there is no separation required. Communication cables are often buried. They can either be a direct burial cable or a raceway enclosing a wet location cable. Burial depths and separations will vary based upon the area it is being buried under. Any types of protection provided other nearby cables or installations and the type of cable or raceway being utilized. In what location is the installation of a telephone jack prohibited in a dwelling unit? It's a bathroom. Rule 60-400. Due to the presence of water in the bathroom, telephone jacks are prohibited in this location. What device in a building automation system converts electrical energy into linear mechanical force? And the answer is a solenoid. Apparently, this is industry practice. Building automation system converts electrical energy into a linear mechanical force, and it's a solenoid. When installing variable frequency drive and older motor for a building automation upgrade, what should be considered with regard to the load capacity of the motor? The correct answer is to derate to the next lower horsepower rating. What is the most common type of connector used for power over Ethernet switches in building automation? RJ45. Communication cables are to be installed in a conduit run to an outlet box that contains bare electrical power, 27.6 kV. What is the minimum distance from the bare bus bars and opening of the outlet box? So the minimum separation distance is 3 meters. This is in 60-308. -308. Separation from other conductors. And over here in subrule 2, and it says 2 meters of bare conductors if up to and including 15 kV. This is over 15 kV, so it is 3 meters of bare conductors above 15 kV. The circuit wiring for equipment connected to a nurse call installed in patient care area must conform to what type of installation method? It is a class 1 circuit. Rule 24102. Raceways for electrical communication conductors must be installed in accordance with what section? Raceways is definitely section 12. What is the maximum RMS voltage for an audio isolation transformer for a swimming pool installation? So for this question, I went to the back of the code book in the index, looked up transformers. I seen transformers in section 68, which I know has to do with pools, and rule 68602 C says audio isolation transformers must not have an output voltage of more than 75 volts. A coax cable for a CCTV system. CCTV means closed circuit television system. It is installed in an underground run of ENT, electrical non-metallic tubing, I guess, that is to be buried beside an in-ground pool. What is the minimum distance between the pool and the cable? This question I looked up section 68. 68 is known for communication. No, coax is actually it's not communication. It's like radio and TV or some shit. Let's see. No, section 68 is pools. Sorry. Rule 54 is community antenna distribution in radio and television installations. And automatically Rule 54.610 will send you to 68056. So because we're already in 60, no, let's go to 54 610. 54 610. (54-610) says swimming pools, and it tells you cables are installed over adjacent swimming pools placed in accordance with 6854 and 6856. So now it 68054. So you got 68-054. Anyway, you got buried beside an in-ground. So if it's an in-ground pool, it's obviously underground. And separation between inside walls of a pool and underground cables or insulated conductors in a raceway, except for the bonding insulated conductor in a raceway supplying, protected by Class A ground fault, and shall be not less than shown in Table 61. So then again, we are being directed to Table 61. So here we have Table 61, and it says cables with a non-conducting jacket or insulated conductors in non-conducting raceways for communication, minimum being 1. So that's how they got their answer, with the minimum distance between the pool and the cable being 1 meter. What is the required color for the circuit breaker as a disconnecting means supplying an addressable fire alarm system? Really and truly, I did not check this in 32-108. Automatically, you're thinking fire alarm, you're thinking red. And breaker readily identifiable, and also serves as to warn electrician against cutting power to that panel, as it would cut off fire alarm system power. What type of sensor is currently the best technology for most indoor air quality control applications is a carbon dioxide sensor. What is the minimum number of conductors required in a raceway to accommodate 12 lamp remote annunciator panels? It's 13. What can occur when there is movement or closure of a water control valve in a sprinkler system? So, a supervisory signal and restricted water flow in the system. A closed or even partially closed water valve will limit the effectiveness of the sprinkler system and should be dealt with, but it does not indicate flow or that there is fire in the building. Therefore, a supervisory signal will activate. So, because it's not notifying that there's a fire in the building, it's just going to create a supervisory signal. Let's just read the rationale. Fire alarm system monitors the building it is installed in. When an abnormal condition is detected, it will signal an alarm in critical situations or signal trouble in non-critical situations. A fire alarm system will not only monitor the building for indication of a fire, but it will also monitor the condition of any suppression systems like sprinklers. Electricians must be familiar with what device activations will create each of these signals. So, yeah, it's not indicating a fire, so it's indicating trouble, basically. What is the maximum allowable percentage of cross-sectional area metallic wireway used for alarm conductors? And I put 40%. 12-2104 wireways containing only signal and control conductors shall be permitted to contain any number of insulated conductors, but the aggregate cross-sectional area of the conductors and their insulation shall not exceed 40%. Also, they are exempt from D rating for number like over 4 conductors or whatever the case may be. What would be the result if the end of line resistor opens in a conventional Class B fire alarm initiating? So the fire alarm panel will indicate a trouble condition. During normal supervisory operation, fire alarm component conductors are energized and carrying a fixed amount of supervisory current. Any disruption to the circuit through short circuits, ground faults, or opens will cause the system to respond in one of several distinct ways. An electrician must know how each fault affects initiating and signaling circuit and how the system will respond. So we got Chapter 17, installing fire alarms. And then we also have here, why is each individual pair of unshielded twisted pair and shielded twisted pair cable twisted at different rates? And twisting decreases crosstalk again. So we got a double. By having each pair twisted at different rates, the individual conductors do not stay in parallel with each other throughout the cable length. This decreases crosstalk. So let's just take a minute to explore chapter 17. Yeah, chapter 17. Okay, what is the minimum size of conductor that can be pulled into EMT for a fire alarm system? The answer is number 16 gauge, and this is in Rule 32-100 4A. How many wires are connected to a Class A fire alarm manual pull station? It is 4 wires. What is one of the requirements for the installation of smoke alarms in dwelling units in new construction? Must be on the lighting circuit that supplies a mix of lighting and receptacles. When an automatic detection device on a single stage fire alarm system is activated,
Who must be notified? Single stage, it's going to have to notify the entire building. What is the max time allowed for the first stage of two-stage fire alarm system? 5 minutes. Why would you install an end-of-line resistor at the end of the fire alarm zone? It is to provide electrical supervision of the entire system. Where can you find the maximum area that a smoke detector covers? This is from the manufacturer. Why must you observe correct polarity when installing signal devices for a fire alarm? Signal devices are supervised. Which standards should you consult to determine fire alarm performance requirements? It's going to be 24 Colby and 36 and 37 S5. When an automatic detection device on two-stage fire alarm system is activated, who must the fire alarm system notify? The supervisory personnel. Okay, that's a little bit of information about fire alarm. Uh, an industrial building has a properly installed perimeter proximity burglar alarm system. To activate the alarm in such a system when in a protect condition, what would you have to what would have to be done? Walk within certain distance of the building. What is the maximum rated amperage of number 18? Class 2 conductors installed in a raceway. Very simply, you just go to table 57 and you should get your answer. All right, last but not least, before I leave, I just want to talk to you about 16-210 conductors and cables for class 2 circuit wiring. Conductors shall be of copper and shall not be smaller than circuits such as fire alarm or smoke alarm devices. And here we have it displayed here. Now, if you wanted the ampacity of these wires, these extra thin wires, we would go to table 57. So that's table 57. Here we have allowable ampacity for insulated copper conductors of class 2 circuits, and it's based on ambient temperature of 30 degrees. Yeah, and here's single conductors in free air, and here's not more than 3 conductors in a raceway or cable. So this is the end of my presentation here. Maybe I'll see you in the next one. Okay. Bye.